Today we're going to talk about intercept form, which if you notice, it is right here on the top. Intercept form will have your two intercepts, which are going to be P and Q, written in the form x minus the intercept and x minus the intercept. Those are your zeros of the function. It's where they cross the x-axis. The A is just like the A from before. If it is greater than 0, it opens up. If it's less than 0, it'll open down. Now, to find the axis of symmetry, the halfway point, you add the two together, and then you divide by 2. So you're finding the average of your zeros. All right, let's start a problem here. This one is already in intercept form. Right here, we know it's going to open down. Flips the graph over. Our zeros, or our intercepts, we're going to plug 0 into y because that's where it crosses the x-axis. We have a negative x plus 1, x minus 3. What would make that parenthesis equal 0? That would be negative 1. What would make that parenthesis equal 0? That would be a 3. So negative 1, 0, 3, 0. Plot those. Negative 1, positive 3. We know it's opening down. What is the middle between those two numbers? Well, you do negative 1 plus 3, and you divide by 2. That is going to be 2 over 2, which is 1. So, we have a vertical dotted line at 1 that cuts your graph in half. To find the vertex, which is the y-coordinate, or the x and y, the max or the min. To find this specifically the y-coordinate, we plug the axis of symmetry back into the original problem. So we're going to have 1 plus 1, 1 minus 3. So we're going to have a negative, and then parentheses 2, and then a negative 2. So a negative times 2, so think of this as a negative 1. Negative 1 times 2 is negative 2, times another negative 2, well, that is 4. So your vertex is at 1, comma 4. And remember, so 1, 2, 3, 4. It opens down. And that would be your graph. All right, let's say you wanted to use Desmos for this also. I already had it plugged in for us. We have negative, and we have x plus 1 and x minus 3. If you want, you can use your table. You can see where it crosses. So at negative 1, there is a 0. And at 3, there is a 0, which we got from our original problem. And our vertex is 1, comma 4.